We're going to skip, so this is chapter 4, it's still quadratics. I'm going to skip 4.1 because all 4.1 is just graphing with like calculators or Desmos, which we've done before. Okay. Now, up till now, we've found the axis of symmetry, we found the number of x-intercepts, we found the y-intercept, we can find the vertex, we can go between standard and vertex form now. What we're going to do now is we're going to find the x-intercepts. We're actually going to determine them. Okay? So 4.2 is all about determining the x-intercepts through factoring. Okay? We've done this before. We did it in grade 9 or grade 10, Hidden Foundations 20. So this is just a nice little review. Hopefully we don't have to spend a whole lot of time on this. Okay?
Oh, I love this stuff.
Okay.
Who doesn't love this stuff? This is the easy stuff I like. This is the only stuff I like about this class.
Is the belt there?
All right, so if we factor these, and remember the x-intercepts, this is when y equals 0, right? So you make y equal to 0, and then solve for x. Okay, and there's a few different ways to do this with factoring. I'll show you a variety of different types. Right? There's difference of squares, there's perfect squares, and then there's just ones with like a coefficient in the front where you can take out the common factor. Sometimes there is no common factor, and then you got to find a middle term and an outside term that will add together, right?
That's fun stuff.
It is fun stuff. Okay. So I'll show you guys a couple here. Let's begin with something like a real basic one, just to get everyone's kind of head in it. Okay. So for example, x squared minus x minus 6. So remember, you just do the two brackets. Remember, you look for factors of the last guy that'll add up to the middle term. So how can I get negative 6 and negative 1? All factors of 6 are 6 times 1.
2 and 3.
3 times 2, right? Yeah, 1. Right, 2 times 3, right? 3 times 2 will give me 6. Now to make that negative 1, negative 3 plus 2. Now remember, I'm actually solving for the x-intercepts here, so this is supposed to be equal to 0. So then to solve each one, I split each bracket, make them both equal to 0. So I have x plus 2 equals 0, x minus 3 equals 0. Then I just solve. So I know this one, x equals negative 2, x equals positive 3. Okay? Yeah. All right, so those are my x-intercepts. So I know on my quadratic, I can tell my a value is positive, so it opens upwards, and I got an x-intercept at negative 2, and 1 at 3. So I'm just going to do something like that. There's your basic sketch. Oh, and I can see my y-intercepts at 6. Okay? We're all okay with that so far?
Yeah.
If not, speak now.
I don't know how that is.
I keep using it.
All right. Now, it's not always going to be that simple. I'm just going to rattle off examples here, guys. So just let me know. So let's say we have something like 3x squared plus 3x. Well, this is going to work out to be the exact same thing. Alright, scratch this one.
Wow, what a guy.
Well, that's going to be the same thing too. Alright, let's just start this one. I'm not going to finish this one because it's, once you guys see how to do it, it's pretty easy. Alright, here's this one here. So now I have an actual coefficient for an A value that's not 1. Okay?
Yeah. The first one but doubled.
Yes, I just doubled everything. I didn't realize that. I just grabbed one out of the textbooks. So what you do here is you look. If I have an A value, check to see if you can factor it out of everything first. Okay? Which I can. So if I divide everything by 2, it's just going to look like this. Okay, does that make sense? We all remember how to do that? Common factor? And then you can just factor it like we did before. Okay? I'm not going to go through it because we just did it. Now, let's take out another common factor. But this time the common factor out front is going to be a fraction.
You're kidding me.
No.
That's at least a joke.
Now, just like before, what I'm going to do is I'm going to take out a fraction, right? So I'm going to divide everything by a half. So I put that out front to show that it's still there. Now, what's 1/2 divided by 1/2? 1, right? Anything divided by itself is just 1. Now, what's the actual rule for dividing by a fraction? You flip and multiply, right? So basically, all you do is you just times everything by 2. Does that make sense? So what's -1 times 2? -2x. -4 times 2? -8. And now you can factor this one. Okay, so factors of 8 that give me 2?
2 and 4.
2 and 4, right? So. And when you have a factor out front, don't worry about that. That doesn't change anything. Your x-intercepts are still going to be -2 and 4. Okay. So far, so good? Okay. We're all okay with having a fraction? Basically, you just take it out and times everything by the denominator. Or by the reciprocal, because sometimes you might have like 3/4, so you multiply everything by 4/3. Okay? Okay, we'll come back to that. Yeah.
No, not that one.
What's language?
Okay, next example. Here I have an A value that's not 1. Right? And I can't take out a common factor this time.
Is that a y in front?
Yeah, y equals. So these are the ones where you got to play around with the brackets a little bit. How?
No. Do the same thing.
No.
Not quite. There's a formal way I could have taught you guys this, but this is, once you get this figured out, it's easier, okay? So I'm just trying to save you some time. It's a little more frustration in grade 10, but I'm hoping by now it's a little bit easier to do this stuff. 2x squared we know is 2x times x, right? Now, factors of 5. What are multiples of 5?
5 and 1.
5 and 1, right? It's pretty easy. 5 is a prime number. So now what I do is I have to put 5 and 1 in here. Okay, so if I go, I'm going to do it wrong at first.
Okay.
So don't write this down just yet. I'm going to do the question wrong, and then we'll do the check. So I'm going to put 5 and 1 there. So what you do for a check is, remember, you multiply your middle terms together. 5x. I multiply the outside terms together. 2x. Does that add up to my middle term in any way? No, so it's wrong. Oh, I don't know why I bothered. It's easier. All right, so let's try it again. 2x and x. Now I'm going to put the 5 over here, and I'm going to put the 1 over here. So now let's combine the middle terms. 1x, the outside terms. 10x. I can give you 9x. If I make this, it has to be negative, so I make this one negative and this one positive. So to do that, positive 1, negative 5. And now it's almost done, but now I got to take each bracket and make it equal to 0. So 2x plus 1 equals 0. X minus 5 equals 0. This one's pretty straightforward. 5. Divide both things by 2. Like so. So there's my x-intercepts. Okay? Cleared some cobwebs?
Yep.
Yeah? Sure? Okay. We've done lots of this before. We did in grade 10. We did lots last semester. So hopefully this won't take you guys too long to jar a few things loose. All right. How are we doing for time? Good.
Still like an hour.
Yeah,
Oh, that's cool.
You got a bloody nose there, Mr. Roberts?
I do. Yes.
This does that for fun.
Yeah.
said that yesterday as well.
All right, I'm going to try one now that you haven't seen before. Well, I guess I should show you real quick. Do you guys remember what to do when you have something like this? This is a difference of squares.
Positive 6 and negative 6.
Right. Plus 6. X minus 6. Okay. Whenever you have two values, and you can take the square root of both, and there's a negative sign, you write it out like this. Put the square root of both in here, you add it, and then you subtract it. Difference of squares. Okay. I know I've taught you that before.
Yeah, you have to.
Okay.
Even I remember that one.
Good.
Who's Tristan?
You remember that?
Tristan. Who's Tristan? That was
All right.
Tristan.
Now,
Tristan Kale. Tristan Kale. Who's gross? Just like me. Oh my god.
whoa,
She.
whoa.
This is not some like, I don't know, weird stuff. This is good.
It is like a polynomial. Very good. This is a quadratic and a polynomial combined.
Actually, I was
Yes.
kidding.
No, so it's good.
What does that word mean?
Polynomial.
Yeah.
Poly means multi.
Yep.
Nomial means
Number.
so it's multi-numbered or multi-variable.
I can do that.
Yeah, you can see all the multi things going on there.
Yeah.
Now, what's nice about this is you don't have to go like distribute this. You don't have to square this and distribute that. Okay. There's an easier way of doing this based on what we've learned so far. All right. When you look here, you'll see a couple of these. I think I even have one on the test. If you look inside each bracket, because they're both exactly the same, we can substitute them out. All right, I can use substitution. All right, so I could say W equals X plus 2. And when I do that, I can get rid of all my X plus 2's with W's. So it looks like this. 12W squared plus 24W plus 9. Now, is this something that's a little more recognizable? Right? We've worked with these things before. Now, I can't take a 12 out of everything, unfortunately, but I can take a 3 out of everything. So I'll make my numbers a little bit smaller to work with. Oh.
How's this gonna work out?
Watch. Factors of 4.
2 and 2. Or 1 and 4.
I'm going to go with 2 and 2.
Yeah.
Factors of 3 are pretty straightforward. 3 and 1. And what's nice is because both of these are 2, it doesn't matter where the 3 and the 1 go. 2 times 3 is 6. 2 times 1 is? Does 2 and 6 add up to 8?
No. It sucks sometimes, doesn't it, Mr. Weber?
All right, now I take this. Now that I've factored it down, I take this and I plug the X plus 2 back in. These are a little bit more work. Everyone still with me? Is this okay?
Yeah. I didn't know you could put brackets inside brackets.
Oh, you could put brackets inside brackets within brackets.
Oh.
Yeah, you can have brackets, 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 all in brackets. Yeah. So yeah,
That's
yeah.
cool.
It gets it sounds cool until you see it on a test and you're like, oh.
Doesn't.
So now I'll take each one of these brackets and I'll solve for x because it's all equal to 0. Remember? So my first one would be 2x plus 2 plus 1 equals 0. 2. So if I work this out, all right, 2x plus 4 plus 1 equals 0. I hope you guys don't mind. I'm just going to kind of work through these a little bit quicker. 4, oh, I guess I'll show my work. What the heck? 4 plus 1 is 5. I bring the 5 over, so it's negative, and then I divide both sides by 2. Negative 5 over 2. Leave it as a fraction. Don't put negative 2.5. All right, then my next one, 2x. So that's 2x 7 over 5 by 2. Okay. Questions, concerns? Okay, now, the textbook will use some different jargon for x-intercepts. X-intercepts could be known as, we could call them the roots of the equation.
Whoa.
Okay, or the zeros. Conceptions. Good try. Good guess, actually. That's not too crazy. Okay, so it could be the x-intercepts, the roots, or the zeros. Did I ever asking for any of that? It's just asking for this.
Okay.
Okay. Completing the square. Okay, let's leave it there. On page 229.
Yeah.
Um, 1 to 10. Just do like A, B, C, or A, C, E, like every other one, okay? Sometimes you might see something like this, guys. Do you guys know what to do with that?
I know.
Yeah, bring everything over to one side, okay? That's all you got to do there.
Gotcha.
Ciao.